So very good evening. So hope you're able to hear me. Prashant, good morning. Long time. So are you people able to see my screen?
Yes, sir.
Okay, good. So today we'll talk about we'll continue our discussion of transaction management. Yes. So we were talking about transaction management. Let's carry forward our discussion. Especially we were talking about transactions in the last class. What is a transaction? So generally how you handle the transactions here in Hibernate. So that is what we're talking about. You know, here we have we are working with this asset properties. So we saw atomicity, we discussed about consistency in the last class. So now, first I will talk about durability first and then isolation. Okay, yes, durability. This is one of the acid properties here. So transaction is supposed to possess this property called as durability. So what is durability here? What does it mean? What do you think? Yeah. So when we talk about durability, here it means A transaction is durable, I can say, is durable once it has been successfully completed. All of the changes it made to the DB are permanent. Yes, we say a transaction is durable once all the changes which we do here to the DB transaction, what are the changes the transaction does? If we can store these changes permanently to the database, then we can say the transaction is very much durable. Yeah, that is what it indicates. Yes. So how do we implement this in the programming? How do we make our transactions durable? What do people think?
By committing.
That's right. So we have to by committing. So we have to commit the transaction. So your transaction API, it provides this option to commit the transaction. So once we commit the transaction, so whatever the changes which are done to the transaction will be made permanent, I can say. They will be made permanent. Yes. So say transaction.commit. So example here, that is what the coding part. To make the changes durable, call transaction.commit. Yeah. Okay. Next, the most important property, okay, the which where we need to discuss about it is isolation. This discussion is going to be lengthy, unlike your other acid properties. So what is isolation here? What do people think? what is this isolation? Idea? Okay. Let's see what is this isolation here. So here, if there are two or more transactions that are working on the same data set, that are working, let's say, so transaction isolation will ensure that each transaction thinks it has it is the only transaction which is executing currently. Yes. So when it comes to isolation, yes, we're talking about multiple transactions probably working on the same data. Okay. So transaction isolation will ensure that each transaction thinks it is the only transaction which is executing currently. It is the only transaction which is executing currently and has exclusive access to the data, I can say. Yes. So this is one of the most important isolation acid properties, I can say. Yes. You know what? There is every possibility, and in fact, sometimes it is common that application spaces, sorry, the transactions here, they execute on the same data set. Multiple transactions may operate on the same data set here. But when multiple transactions are operating on the same data set, you see, you may have several issues, okay, which needs to be addressed. So what do people think? What will be the issues if multiple transactions are operating on the same dataset? Yes. What will be the issues if multiple transactions are operating on the same dataset? I guess you might have heard about it. We call them as isolation issues. Isolation issues. So what are these isolation issues? Yes.
Working with same object simultaneously.
That is isolation. Sorry, we were talking about it, but when working with the same data, okay, simultaneously, what are the issues? I'm talking about that issues.
Uh, Basically, a change made by one transaction can get overwritten by the other transaction. So you miss the concurrent updates. I mean, one of the transaction might be overwriting the data which was updated by the second transaction.
Okay, yeah. So actually, that's right. So there is lost update issue. What you're talking about, right? It is called as lost update. You have dirty read.
Yes.
We have, you know, unrepeatable read, and we have phantom read. So these are the various isolation issues. Okay, when multiple transactions, basically, when they are operating on the same dataset, you may come across this isolation issues. I can say yes. Yes. So first, let's start with lost update issue. Let's see. We'll work with this lost update issue here. So now let's take an example here. Let's say you have two transactions. So these two transactions basically, let's say, what are they? Transaction A and transaction B. Now these two transactions basically, they are working on the same data set. Okay, so this is the data set. I mean the row. Data set means the row. So D refers to the data set here. Okay, and here TX means transaction A. And we have transaction B. Now let's say transaction A, first it operates on this data set. Okay, so basically let's say it does an update. Transaction A, it writes, it performs a write operation, or let's say it updates. Okay, updates the data set. Now, say here the transaction B, again, it also operates on the same data set, and it also does an update here. Updates this data set, the same row, same data set. So next here, let's say the transaction B, it does a rollback. Sorry. And transaction A, let's say it does a commit. So will there be any issue here? What do people think? So what do people think?
Yeah, before the transaction A could commit the transaction, transaction B will delete that record.
The changes will be undone. The record will
Yes.
not be deleted. You see, transaction A did an update. Okay, let's say transaction A is doing an update here. And on the same data set, transaction B is also performing an update. Okay, so now after the B transaction B performs an update, let's say transaction B, you see here it is rollbacks. So what happens if transaction B rollbacks here? You see, rollback means the changes done by the transaction will be undone. Then database changes, whatever the changes which have been done to the data set will be undone, I can say. Yes, they'll be undone. So here that means the changes made by both, the intention of transaction B is to just undo the changes which it did. But when you call the rollback on the data set, what all the changes which have been done to this transaction will be undone. Yes, definitely. Yeah. So even the changes which are done by transaction A will be undone now. The updates which are done by transaction A also will be undone. That means we lose the update which is done by transaction A. Okay, we lose the transaction. We lose the update done by the transaction A here. That is the problem. It's going to be the problem here. Yes. So this is lost update issue. This is lost update issue. So let me show you people another example, another case here. which demonstrates a lost update issue. So I guess it will be helpful for you people. Just a minute. Yeah, now you see this here. This is one of the images which I got it from the net. So on the extreme left side, you have a transaction here. On the extreme right side, that line on the extreme right side, left side, you have that line, right? It represents a transaction. Even on the extreme right side, it also represents a transaction here. In the middle line which you got here, it's that product object, okay? A product here on which these two transactions are operating. So first of all, you people give it read. Go through it completely. Just take a minute and just read everything here, what you got here, okay? First do that. Yeah, sorry. So what you understood here, you see on the transaction, you see you have this transaction. So there are names. You see the persons who are operating on behalf of those persons. The transactions are executing here. Alice has initiated a transaction and Bob has initialized a transaction. You see, Alice transaction first it begins. You see what it does. It reads the product details. Okay, so the same product record. It is trying to read the product whose ID is 1, right? And you see now Bob also reads the same data set, same product. Bob also reads the same data set, same product, I can say. Now, here, After reading this data set, Ali's transaction, Ali's transaction first, it does an update. You see what it is doing? It is updating the quantity to 6. It updates the quantity to 6 here. Yes. Okay, it updates it to 6. Now, here, after that, what is the initial quantity? Have you noticed it? Yes, what is the initial quantity here? And that is important. Initial quantity is 7. Yes, you'll find that the initial quantity is 7 here. So, what Ali's transaction did, it updated that quantity to 6. And then later on, after some time, Bob's transaction updated that quantity to 10. And then Ali's transaction commits. That means the quantity is updated to 6. And Bob transaction commits. It is updated to 10. So here in this case, so do you see any issue here? So do you see an issue here? You can see even this is an example for lost update issue. You see that update done by that Ali's transaction is lost here. It wanted to update it to 6, but only you'll find that here update done by the first transaction is retained, right? The Bob's transaction is committed. Okay, you know the main issue is here. The quantity which they read was 7, first of all, and based on that quantity, both are trying to operate on this product. Both are trying to operate on the top product, right? So initially both the transactions will read the quantity as 7, and you see, Live's transaction wanted to deduct that amount, make it 6. Maybe one quantity was ordered by customer, and it is trying to deduct that quantity, reduce the quantity by 1, right? Yes. Meanwhile, let's say Bob's transaction here. Let's say it's an inventory transaction. So when new stock has arrived and they're trying to update it to 10, right? So the problem is here, the actual quantity after executing these two transactions what should be the quantity? Let me tell me. What do you think? Yes,
10.
it is 10. Okay, so it should be 10 now. No, think about it and tell me. Yes, all of you.
So can you repeat the question?
So what will be the quantity after these two transactions execute? If they execute properly without any issues, so what should be the quantity here?
9.
It should be 9. That's right, exactly. It is supposed to be 9. Because you see, a live transaction is trying to reduce the quantity by 1. Initial quantity is 7. It wanted to reduce it by 1. So it should be 6. And then, you see, Bob's transaction here is trying to add 3. 3 more additionally, incremented by 3. Existing quantity, it wants to increment it by 3. That is what it is trying to do here. Yes. So, but what is the issue here? It, again, at the end of the transactions execution, both the transactions after they execute, you see, you have only, you have 10 quantities 10, but it is supposed to be 9. That means Ali's transaction, the update has been lost here. Ali's transaction update, it has been lost. Yes. I hope you people got it. Is it clear for you people, all of you? Okay. I hope you people got it. So this is lost update issue. So how will you address this lost update issue? What do you people think?
By placing a lock on the transaction.
Okay, so what should be the lock here? Yeah, actually, this is where your isolation level comes into the picture. This is where isolation level comes into the picture. Okay, we have isolation levels. Let's talk about it. Just a minute. So we have isolation levels. So each isolation level, see, to address this issue, we have to use this isolation level called as uncommitted read. We have this isolation level called as uncommitted read here. Yes. Uncommitted read. So what is this isolation level? You know, this isolation level uncommitted read, you'll find that here it is actually related to logs, I can say, database logs. What it does basically, we can set this isolation level. Okay, we can set this isolation level on the database side. Here, you will find that a writing transaction will obtain a lock. Okay, a write lock, I can say. A writing transaction basically it obtains a lock here, a write lock. So if it obtains a write lock, what happens? You see, it won't allow the other transactions to update this data set. Okay, here that means in this example, transaction A, it acquires object lock. It acquires an object lock, sorry, a write lock. See, first it updates it and it acquires that write lock. And once it acquires a write lock, it retains that lock it till it is done with the execution. Either it has to commit or roll back. Either successfully it has to execute, or even if it can fail. So that's not a problem. Once it executes successfully or fails, it is supposed to release the lock here. So till that time it will retain this write lock. Okay, till the end of the transaction it will hold that lock, I can say, on this particular data set. Now that means if it acquires a write lock, so other transactions will not be allowed to update this data set. Okay, that means in this case what happens, the second transaction, transaction B, when it is trying to update this data set, see, it won't be allowed to do this. So this way you can avoid this lost update issue. This way we can address this lost update issue, I can say. Yes. Okay, but how do we set this isolation level here? So how do we set this isolation level? Isolation level, uncommitted read. Let's see. You see, we can set this isolation level per transaction, per connection basis, I can say. Per connection basis, we can set this. So we can configure it here in the hibernate.cfg.xml file, I can say. Okay, here we have a property. I'll show you people. Hibernate.connection.isolation. You have to set this property value to 1. So when you set this property value, Hibernate connection isolation property value to 1, you will find that here we are setting that isolation level to read uncommitted. Okay, yes, that is what we did here. So that means a writing transaction will have exclusive write lock on the data set. Okay, so other writing transactions or other transactions will not be allowed to update this record. Okay? Other transactions will not be allowed to update this record, I can say. Yes. But the reading transactions, I mean, writing transactions cannot update this record. Writing transactions means the transactions which want to update this record, they can't do that. But you know what here? The reading transactions, they can still read the data from this data set. Okay. So they will have access to this data. Reading transactions will be able to read this uncommitted data, I can say. Reading transactions will be allowed to read this uncommitted data. Yes. Okay. So hope you also got it. So now, but there is a problem here, even when we set this isolation level. What is it? So let's see, dirty read problem. What is dirty read here? Yes. What do people think? So basically, when we talk about this dirty read, a transaction here reads data that is being changed, that is being updated by another concurrent transaction. Okay. Okay. Another concurrent transaction has modified before the modified transaction has committed or aborted here. Yes. The transaction reads the data that is being updated by another concurrent transaction has modified. Okay. Sorry. Before the modified transaction has, before the modifying transaction has committed or updated, I can say. Yes, this is right. A transaction reads data that is being updated by another transaction before the modifying transaction has committed or aborted. Yes. You see, what is the problem if a transaction reads the data which is modified by, which is updated by another transaction, concurrent transaction, before it commits or aborts? What could be the issue here? What do people think?
That will be the stale data.
Yeah. See, now we don't know whether this transaction which is modifying will commit or update, commit or abort or roll back, right? If it rollbacks, that means whatever the changes which this transaction has done are invalid. Yes, it is stale data, and that stale data, that invalid data, is read by transaction, first transaction, right? Yes. So here, further we can have an explanation here on this. You see, if the modifying transaction rollbacks, that means the reading transaction read the stale or invalid data, I can say. Okay, reading transaction read the stale or invalid data here. Yes, because the changes which were done They were just stored temporarily over there, right? Yes. Okay. So how do we address this issue? Actually, you see this isolation level which we have here, it won't address this issue. So it will cause that issue, that irritant problem. So here we have to set the isolation level to read committed. Okay. So this is read uncommitted. No, this is read committed isolation level. So what if here, if the isolation level is set to read committed, so what it does, so now this read committed will not allow the reading transactions to read the data which is uncommitted. Okay, it won't allow the reading transactions to read the data which is uncommitted. Yes. So this way, that means you will find that here a transaction which is updating the record will have exclusive read lock, but not write lock again. That means if you set the isolation level to read committed, you may have lost update issue. So because the writing transaction will only have read lock on exclusive read lock on that particular data set or row. That means it won't allow the other transactions to read the data, but other transactions are allowed to modify this data. Okay, yes. Till what time the other transactions are not allowed to read the data? Till this upwriting transaction is committed or rollback. Yes. How will you set this isolation level here? You see, here you set it to true. Two. I'm sorry, two. The property value you have to set it to two. You can address this issue. Okay. Read committed value is one. Read uncommitted value is one, and read committed value is two. Next, we have another isolation issue. What is it? Unrepeatable read. So, what is this unrepeatable read here? What do people think? No idea. Okay. You see, unrepeatable read means you see when a transaction reads a data set, when a transaction, reads different data, each time it queries a particular data set. Yes. You see, a transaction reads different data each time it queries a particular data set, I can say. Yes. Let's say a transaction is reading a particular data set, means a row. Within the transaction, it it tried it read that data multiple times. Okay, let's say it read the data twice. It read the data twice, let's say. So what happens? Each time, two times it got two different results. Two times here, it got two different results here. Yes. So what could be the reason? Yes. This happens because in between multiple reads, another transaction is updating this data set, I can say. Another transaction is updating this data set. Yes. Because of this, you may get this issue. Because of it, you may get this issue here. So what do you people think? How do we address this issue? Yes. So you see, when a transaction is reading, so other transactions should not be allowed to read the data. In that case, we'll be able to address this issue, right? Other transactions should not be able to update the data. Yeah. Just a minute, please. Yeah. So you will be able to address this issue using a repeatable read isolation level. Repeatable read isolation level, I can say. So the value is 4. You have to set it to 4 here. This way. The isolation property value, set it to 4. What happens now? A reading transaction will have exclusive write lock on the data set. That means it won't allow the other transactions to read this data. It won't allow the other transactions to read this data here. Yes. Okay. That is what happens. So this is about repeatable read. What about phantom read here? Phantom read. Sorry. The isolation level is phantom read. So what is phantom read issue? Sorry. Phantom read issue. Here I can say that it is similar to unrepeatable read itself, phantom read. Okay, you'll find that here I can say that data changes in a current transaction by other transactions is called phantom read. Cause this happens because new rows will be added because in between new rows are added by other transactions. So you get a different number of rows for the same query. You get different number of rows when executing the same query multiple times. Okay, in a transaction you're talking about it. Okay, in a transaction, yes. So what is the difference between unrepeatable read and phantom read here? Yes. What is the difference you found here? Can you people tell me? You see, when we talk about unrepeatable read, we are talking about only one row, whereas phantom read, we are talking about multiple rows. That's the difference here. Okay, we are talking about multiple rows. That is what we are talking about. So that is about phantom read. So a transaction is reading multiple records. So far we are talking about a single data set, right? But now we are talking about multiple data sets here. Okay, we're talking about multiple data sets. So how will you address this isolation issue? What do you think? Okay, you know, in this case, you see, so we can actually address this phantom read issue using serializable isolation level. Serializable isolation level here. You know what? Serializable isolation level is considered as the most strictest isolation level here. It is considered as strictest isolation level. Okay. What happens if you set the isolation level here? You know what? If you set the isolation level to serializable, you will find that a reading transaction or writing transaction, both, okay, a reading transaction or writing transaction, they will have exclusive read and write locks, I can say. They'll have exclusive read and write logs. Yeah. So that means here no other transaction will be able to read or write this data. When a transaction is working on the data set, no other transactions, they will be able to execute this transaction. I mean, they will be able to read or write. So this is considered as the most strictest isolation level. This isolation level is actually considered as the most strictest isolation level here. Yes. So generally, the isolation level is not set to serializable. Okay. Yes. So this way we can address this isolation levels, I can say. This way we can address this isolation levels. Yeah. Sorry, isolation issues using that isolation levels. So, you know, to address the lost update issue, there is an alternate. Instead of using that isolation level read uncommitted, we have an alternate solution for it. Is anyone aware of it? Have you people heard about it? You know, we have an option here, I can say, definitely, for especially for lost update issue. To address lost update issue, we can use something called as versioning. Okay, versioning here. Have you people have ever heard about this versioning? Yes, versioning. You know, we can add a version column. We can add a version column here to the table, and yes, in Hibernate also we have the support for this versioning. So with the help of versioning, we'll be able to address this lost update issue, I can say. will be able to address this lost update issue. But I want you people to try this. So will you people try this, all of you? Give a try. Okay. Yes. So anyways, I'll explain it. But meanwhile, I want you people to try this. Okay. Yeah. So next thing here, I would like to talk about fetching also here. Fetching strategies. What are fetching strategies? Yes. What are fetching strategies here? Fetching strategies basically, it talks about the way the records are fetched from the database server. Okay. By default, I can say that Hibernate follows lazy fetching strategy. Lazy fetching strategy here. Lazy fetching strategy means what? When I say lazy fetching strategy, what does that mean? Yes. You know, it is all about fetching the associated records. Whether you see whether they are fetched eagerly or lazily. Lazy means until and unless you read the data, you won't get it. For example, we have this one-to-many association. Okay, I'm using get method to fetch the record, right, based on the ID. You know what? As we have discussed earlier, so without any issues, this item record will be fetched eagerly because we are using get method. We have another method to fetch the record lazily. What is that method? We did discuss about it. What is that method? If you want to fetch this record lazily, we have a method for
Load.
that. Load method. That's
Load.
right.
Yeah.
Load method is there. So you see, as of now, this item object will be fetched eagerly, no doubt about it. But what about the associated objects? Will they be fetched eagerly or lazily? That's the question. I mean, lazily means, eagerly means immediately it will hit the database server when we run this program. What happens? So when you call this getBits method, it will immediately fetch this records. That's it. If it is eager fetching. Otherwise, you know what here, until and unless you try to work with this collection, until and unless you read the records from the collection, on when you perform any operation on the collection of objects, associated objects, then only the records will be fetched if it is lazy fetching. Okay? Yes. What do you people think? In this case, will it be eager fetching or lazy fetching? Yes. Actually, the associated records will be fetched lazily in case of one-to-many association. By default, Hibernate follows lazy fetching strategy in case of fetching the associated records, I can say. Okay, so that means, yeah, until and unless you try to read or perform any operation on the collection of collections here, which is the associated records, they're fetched, they won't be fetched. Yes. So why it follows lazy fetching strategy here? Why it won't fetch the records until and unless you read that elements or read that associated records? What is the reason behind this? What do you people think? Yes, because just imagine, you see, here, for suppose, for that item object, let's say 10,000 bits have been placed. Okay, on that item object, 10,000 bits have been placed. So that means this item object is associated to 10,000 bits. Now, if whenever I fetch this item object along with that item object, immediately if the 10,000 bit objects are also fetched from the database server and stored in the memory, don't you think it is an issue? Irrespective of whether I need that associated bit details or not, irrespective of whether a user needs that associated bit details or not, you see, if I try to fetch that associated bits, what we are doing unnecessarily, we are loading that objects into the memory, 10,000 objects into the memory, and you see, we are blowing up the memory. Yes, especially in case of one-to-many. You see, one object is associated to many objects, right? You see, item is associated to many bits. So whenever you fetch item, along with it, if all the associated bits are fetched, irrespective of whether no matter whether you need them or not, whether the application needs them or not, that is going to be a problem, right? Waste of memory, waste of resources. So Hibernate will follow lazy fetching strategy for this. Okay. Yeah. In case of one-to-one, one-to-many, and many-to-many. In case of many-to-one, one-to-one, it follows eager fetching strategy for associated objects, because you see only one other object is associated, right? It won't be a big deal. Yes. Fine. So I will show you people with examples in the next session. Okay. Yes. I mean, we are going through the examples only, but I'll show you how to fetch this lazy fetching, eager fetching. We have the configurations. We can do the configurations here. Let's see how to do this configuration. Okay, but I'll talk about it in the next session. Let's do one thing. Let's meet tomorrow. First, I'll complete this fetching strategies in the next class. It will be a small topic itself. Maybe for 15-20 minutes we'll discuss about it. And after that, I'll be starting with caching concept, Hibernate caching, first level and second level caching. We'll go through it. Okay. Yes. And then we'll see bulk updates and we'll close with Hibernate. We'll start with web services. Thank you all. Bye bye. Let's meet tomorrow.